Hi, everyone, and welcome to today's session on LLM optimization techniques. We're so glad to have you here as part of the anitabi.org India community. Today's session is led by someone many of you already know and, of course, admire, Anupama Itikirala, a longtime active member of our community who brings both deep technical insight and a passion for leveraging tech for good. Anupama's journey began in the CPO era, and in today's fast-evolving world of AI, she continues to stay ahead of the curve. She's the founder of Mayuk.ai, a fintech company, and is also actively involved with startups shaping the AI landscape. So whether it's speaking at tech forums or mentoring young technologists, Anupama is always ready to share her knowledge. And we're thrilled to have her here with us today to do just that. Let's dive in and explore some powerful techniques to optimize large language models. Over to you, Anupama.
Yeah. Thank you, everybody. Thank you, Karen. Thank you, everybody, for joining. Hopefully, I'm audible and visible to everyone.
Yes, go ahead.
Okay. So the topic I choose for this evening is LLM optimization. I know it's a little different topic when we look at from the era of the LLM agents and the AI agents being spoken at a very high level. But then what I discover in my experience is the core is core always. And we told the LLMs probably there's nothing much we can do even if we think about the agents or the orchestration. So something about me, interestingly, Karen has said, yes, I've been associated with GSCA since 2015 that I was working for Intel as an enterprise architect. And that was my last job. So for people to inspire, I'm actually a person on career break from technical perspective. And that gave me to explore a fintech based on the artificial intelligence. I have two projects that I'm prototyping. So far, not seen success, but then that made me a 29 years professional staying in this industry. And I've seen right from CPUs. I remember my early days in 98, 99, where I used to fight for CPU memory. And today I see the era of the GPUs, people fighting for GPU space. So that made me to choose this topic. So that's it all. And hopefully many of you know LLMs, right? Some buzz, yes or no?
Yes.
Yeah. So LLM could be anything, right? Right from the scrapping of the web, be it OpenAI, be it the cloud, be it the ChatGPT. But then when we talk about the large language model, there's a section called natural language processing in the artificial intelligence. That's what it turns to be. And that's where you see on this side of the right side, something like NLP, BERT, NLTK. All this is the practices. Somewhere in 2018, that's where I started working with AI. That was a big fight to even look at and get some data out of it, because there was only SPACY and LTK kind of libraries. But then one interesting thing we see in the era of the ChatGPT is the tokenization. So whatever we give to ChatGPT as a stream or a prompt or anything, when it goes down to the GPU or CPU, it is called as a byte pair. That's the minimal data set. We don't have anything like int, decimal or anything, right? For people, those who came from the Python or Java or any other data structures, in terms of the particular LLMs, it's all byte pair is the minimal unit. That's where we actually end up spending a lot of money, a lot of dollars. And that's the reason I wanted to spend a little time here. So when we do a BP, a tokenizer, it gets into BP, and that's how it looks like all tokenizers. And those of you who have worked with NLTK or words or embeddings, you know how it looks like. So when it comes to the use cases, most of us know that the code generation, the chatbots, question and answer sessions that we see on most of the AI-enabled websites or the mobile apps, we see them, and that's the application. And most interestingly, the language translation. Anybody used this Sarvam from India? They are the first one from India who actually developed 50 different languages, and they're enabling a lot of grassroots level innovation in terms of the AI, and that's possible because of having the LLMs in local languages. And all of us as the chat GPT users do know about the prompts. So this is how the world of the LLMs look like, a big ocean with so many things, so many players around. Of course, chatbots and all that thing. More interesting, the media and the content and automations, like the children plays or something, the cat, mouse kind of a Disney world also can be done with this. And most interestingly, this LLMs is more going towards the Gen AI. So that's where I said I've seen CPUs to GPUs. And coming to the LLM optimization, why do we need them? Even if we use something like a databases in the old era, in a full stack, we do use databases and we normalize them, right? That's because of building the precision and the query capability and accuracy. The same thing is being done when we talk about the LLM fine tuning, and the life cycle we do have is something like scope them, what you want to do. It's more like to give an example that if today I want to, in Hyderabad, we're having Miss World thing, right? The gamut is going on here across the hotels. If I want to know a particular Miss World from the entire world of the Miss Worlds that have happened, I definitely need to tag them as a 2025 or 2024 to know. And Telangana Jarurana is another one, which is more of a Urdu or Hindi. If I give this and I want to know who all participated, that's where I scope the entire LLM and I scrap if there's one about the Miss One, right? I scope that and then I specify the task if I want to look at the media, because when I scrap, I can see the event that happened in Charminar yesterday, the Ramappa temple. So I have to give this. Why I'm doing this? Again, the tokens that are costly, they may not get the right one. So I scope, select, and adapt the model. So adapt the model is where we are doing prompting. And then below the layer, when we do this, we have to fine tune the parameters based on that. When I spoke about the Miss World 2025, of course, the 2025 and Miss World is one of the tokens. But the fine tuning happens when I want to retrieve the media and the videos is either Charminar or Ramappa, right? So then we evaluate, optimize, and bring out those augmented models to do something with that which we want to do an interesting fashion parade or something, right? If we want to talk about Batukama in Hyderabad, probably somebody would use that tomorrow. That's exactly scope. Of course, here I picked up a scope with the healthcare, but that's not the intent that I wanted to cover. But for people who are watching, that they can. So LLM fine tuning, why we do it? Because it is relevance specific. We want to improve the accuracy and more or less above all is customer interactions. Why I picked up Miss World, you may wonder. We are a strongly women community. Do we find any male participant in Miss World? No, right? So the customer interactions, if we want to see male, probably they are into business, like the Lord Bazaar people who are actually sold them. That could be one. But again, if we see the data privacy and security, usually in a visual kind of a context, there will be their measurements, body measurements like height, weight, waist size, and all. When I try retrieving some data about the beauty, knowing about definitely how to hide, this is where I actually modelize. And when I do optimize or display the model, I put certain inside strings. So that's what it is, and there could be hallucination. The hallucination in this particular example, I can think if some woman is like 5'10", and if she is lean, probably in the video you may mistake it is a boy, right? So how do we remove those hallucinations? So that's where when I do a parameter modeling, definitely I would like to say hair color or the hair length or having bangles like that, that I do. So that's what is the LLM fine-tuning regions and the techniques we do have. Like I spoke about the parameters. I spoke about the batch sizing. It's like maybe I would like to get from each geography, those things. So this diagram says that we do have different techniques like prompt optimization. We are aware the fine-tuning we spoke about, and everybody who are probably advanced know about the RAG, vector story, vector databases. And guardrails is another one which can actually increase the privacy and security. And the most interesting thing that I probably would address in this one is the GPU optimization. That's where, from a startup perspective, I saw I burning my money. Why we do all these things is to just simply scale the solution, increase the resilience, reduce the cost and increase the security. So now coming to the techniques, am I okay with the speed? And I'm going speed, fast?
No, all
Uh,
good. You can
Good.
keep going.
The flow is good. So as a theory, we only see 4 different types of LLM optimization techniques called quantization. The quantization again is 16 and 32-bit. I'll come why I spoke about the byte per BPE kind of a measure at the token level. And pruning, as the synonym goes, is cutting down the branches of a tree, meaning that I remove the data that I don't want when I do the fine tuning and optimization. And knowledge distillation, there's a very great example, known example of a student teacher, meaning the teacher, whatever the exhaustive knowledge has, she or he has, will transmit that to the students. So that's called knowledge distillation pattern. And LoRA is another one, which actually talks about maintaining the performance with the fewer parameters. Am I audible? Karen,
Yes,
my slides
yes,
are visible. Okay, this is
your
I think my
it's back now. Yeah, it's back.
Yeah, seen right?
Yes, yes. Go ahead.
So when we say the is it in right mode? Visible my slides? Are my slides visible?
It's on the
Okay.
LLM optimization page.
Yeah, but the slides are visible to everyone, right?
Yes.
Okay. This is what I said when I say LLM teacher and student. That's the distillation example. Distillation is more like spreading the word, right? So being a NLP, what it does is whatever the teacher has the vast, it will transfer, but when it does the fine tuning, whatever the small context the student can learn only be transition in this distillation technique. And quantization has 16 and 32-bit quantization. There are different techniques that I'll talk about, and pruning is what we see is a pruned LLM. And most interestingly is all this can be written with a Python code. I'll just show one example in the last. And
Anupama,
like
can
we
you please go
see,
to presenter mode?
that's what I was looking at. Is it coming now?
Not yet.
Yeah, is it coming now?
No, I think you'll have to go down and press that. Yeah, yeah. Yes, now we're good.
See, the most interesting thing is all these are dependent on neural networks. So when I say there's something being optimized or fine-tuned, based on the weights or some other technique, it has to deep traverse. And that's where we actually consume a lot of memory, a lot of speed factors would come. And that's where we see this full model retraining, what kind of a strategy we want to adapt. In the theory, we say that reduce the model size and improve performance. Like the example I've spoken about the Miss World contest. If I want, when I say that I want to only see a Ramapar, Charminar kind, I said that the model size would be extracted subset so that I only get it. But then if I say Miss World Telangana 2025, I would get all the information extract from the web or some other source, right? So, but then I will not get who has what kind of people from which nation has been participated. But also it takes a lot of time because it has to do a traverse. It's more like a decision tree analysis that we know all of us in the data structures. It would do that. And most interestingly, the CNN and RNN techniques are used. The recurrent neural networks and the convolution networks. So in practice, only small percentage in LLMs are zero waste. That's where we are actually cautious about the memory. Of course, the benefits that we have been speaking, like the performance, hallucinations is a big thing that we all know. So by adopting a fine tuning, we want to get a better accurate model and also reduce, pruning is like reducing unwanted, that's what we see, and a consistency. And then privacy is prevent leakage. I shared the example, the women misval kind of a thing, right? A women being described. We don't want that. We just want who has participated. Of course, the cost, because every token that we pass, be it a computer vision algorithm or NLTK, costs a lot by the time it reaches the CPU and giving the back the query that we want. And then the reliability is most important because we want to get a lower, faster speed, right? The control uptime, the 99.9996, whatever the cloud we say, availability, reliability, those are applicable here too. And now the inferences. We all know that there is a thing called references and inferences. In LLM, we only talk about the inferences, which is a process of the pre-trained language model generating text outputs. This is very much related when we do a chat GPT prompting. We understand this technique that we are trying to give an inference. The example I said, Miss World 2025, probably it belongs to the India. One another thing, when we say Miss World 2025, probably there could be some other unwanted data also may come, some kind of a our war-related information may come, but that's not what our interest is. So we want to predict certain model with a sequence of words. So that's why probably we say that Miss World 2025 Telangana, or if we say Miss World 2025 India, there could be some other critics, some other hate talk also may come. So we want to remove those, essentially creating a new text based on, that's what it is like. So it's extracting from a huge vast set to a small subset. And then the challenges is the computational cost, because billions of parameters have been fine-tuned, which requires huge computational power, where the data centers have to be offering us in the real time. And the memory requirements, because when we, even if I use a vector DB kind of a thing, it still uses a lot of memory because it has to go, retrieve, come back, match, and do. And all of you know that how the neural networks does work. That's a challenge here. And latency and scalability, the nature of token generation in the decode phase introduces latency, and scaling the model to handle requests simultaneously can be challenging. I pause here for a minute to bring back a technique like a BERT, a transformer architecture. Maybe many of you know, by the time these LLMs have come into the picture, there were a lot of decoders. Google had a few of them. There was decoder architectures, transformer architectures, where they actually, instead of doing a bag or a word, a query, they do decode a lot and help us in the process. So when I write a code for in the Python or Java, I specify which model I want to adopt in the transformer architecture. Each company has a different one. So most people do know the transformer architectures like BERT. This is not about the transformers, so I'm not talking about those. But we do have some interesting tools to help us with this. When I want to get a batch prompt with a maximum speed, I can use a library called VLLM. When I do an inference, I did not spoke about inference. I'll talk after this, for the reason that I just wanted to introduce the tools first. And when I do opt for text generation inference, only text I want to retrieve, then I just go for the Hugging Face, because there is a multiple adapter architecture for the core model. Do remember, when I talk about these models, I'm not creating a LLM, but I'm just fine-tuning a LLM like Hugging Face or Gemini or ChatGPT. And the translate too is good when the speed is important and we want to run inference in the CPU. Do remember that I can run certainly LLMs in the CPU too, especially when I just do a small language model. There are also small language models that we speak, whether we speak about the large language models. I can use just the C translate too, so that the cost is less, the accuracy is more. And OpenLLM, many of you may know, is a way to connect adapters to the core model. Again, the Hugging Face agents come into the place here. I can use some of the capabilities of PyTorch too. That's where I said I can just import the BERT model or some other open LLM model, and I extract from that. And another one is the Racer, which is more like a pipeline used in the deployment scenarios of MLOps or those things. And MLC LLM is a client-side computing. For example, if I want to write a chatbot on my mobile, the mobile works on open edge systems. The deployment does happen on the edge systems, which have lesser memory. They do have challenges in the internet scenario. So in those scenarios, I use MLC LLM. DeepSpeed is another example, very famous one. It's a library. Want to deploy the LLM. So when we see the cycle, we have something to develop. Some of the libraries can be used in the development, like using PyTorch. Some of them can be used for the only deployment on the LLM, the open edge. Some on the DeepSpeed, like the LLMs at a larger scale. So now I'm talking about the quantization that we spoke earlier. Is it okay, everyone? I see some few people.
Yes, all good.
Yeah. If there's anybody, and it's only 14 of us there. So quantization is a technique where we want to speed up the GPUs by inference. The inference we understand is like I'm passing a synonym or similar word. I can say Miss World 2025, or can I say beauty peasant as well? Beauty peasant in Telangana, maybe it will bring more, but the famous one that will come up the stack is Miss World that's happening today. But how do I get that? Because there are a lot of neural networks. So what I do is when we talk about the inferences techniques in the LLM optimization, I have to pass an inference so that the neural networks can be searched or sorted. You all know that in artificial intelligence, we only have the sort and search algorithms, nothing else. I can't do any other manipulations there because the data is what being retrieved. So either I reduce the memory or I increase the speed to get the accurate data. But when I reduce this footprint or the memory, I may not get a lot of speed or get the accurate that these are the challenges. So what this quantization does is it creates a tensor fusion where multiple operations can be merged into a single operation. It's more like your vector merge that happens or the data structures of hash or bucket that you use. This is a technique that uses on top of the neural networks. And it contributes to fast inference by reducing the overhead of managing separate operations. We know all of these techniques in a different context when we use the full stack, but we are hearing it for the first time. TensorRT from NVIDIA is also a famous tool, very popular. Actually, there are many. I just picked up two which are used in the industry very widely. So this tool is optimizing LLM inference, such as kernel tuning and in-flight batching. Do understand that I'm talking about a batching scenario here. So when I use a batching scenario, I can get multiple data, unrelated data too. But then why I do that is like that's a faster thing that I can go down till from my upper layer where a query in the chat GPT or somewhere from till I get back. I need to do this. So NVIDIA, as you all know, is a famous one when it comes to GPUs. We do have HP GPUs. We do have other companies' GPUs as well, even Amazon offers. But NVIDIA, even Intel has the GPUs. But NVIDIA is an industry-wide proven popular one. Cost is little high, but people use it for the performance and the speed. So the performance, again, here, when we use the TensorRT, it can be 8x faster inference. In the CPU-only platforms, do note this. I'm talking still about the CPUs. What it means is, when I deploy my large language model on my probably 8 GB RAM and something like one data center which has 1 TB of data, still it will work. But in reality, in the whole world of the AI, it's not the fact. It will be jillion bytes, or more than that. So this TensorRT is suitable when we want to do a CPU-only operation. So the performance scale is for the real-time applications. like chatbots, recommendation systems, or autonomous systems. The context we have been setting right from the beginning is when we work with the LLMs, my scope of talk speech here is I'm only emphasizing on chatbots, Q&A kind of a thing, so that we can understand and adopt the usage. Now I'll say, coming to why GPUs. I said till now CPUs, right? Even CPUs can, why I'm burning my past going for NVIDIA or some other one. The interesting thing here is there's a massive parallel processing mechanism that happens. And they can handle the extensive matrix operations and data flows inherent in LLM training and inference. I've been saying that it is all neural networks. And believe me, when these graphical process arrays have happened, they adopt a lot of matrix operations. A real-time numerical analysis does happen to see in which core my data is residing. If to drive back the municipal context that's happening, see, the Ramappa unit may not have a central server to put the data in the same data center. Maybe they do have another server to host their local things, local videos or local news. And even these people, whoever have taken from the mobile, the context also will load their data, right? So will a CPU be enough? No. That's the reason we want to talk about multiple cores. When I talk about multiple cores, there are different algorithms, one core to the other speak. Just like in cloud, when we talk about this artificial intelligence and NLTK or LLMs, we talk about compute, storage, and processing. Without that, nothing is there in the computer science part. So when this comes to the GPUs, these are graphical arrays because they have to see which node, which core has what information and form a neural network, compute the weights that are associated and get back as the data. So when I say GPUs are designed with thousands of cores that enable them to perform numerous calculations simultaneously. These are the mathematical kind of things, and NLP tasks use this. Trust my experience in 2018, 19 was I tried on my own CPU by upgrading a 6 MB RAM. I had nightmares. I wish I have a GPU, but I cannot afford to that today as a startup. So like we all see in the cloud arena, we talk about some metrics like reliability, availability. When it comes to the era of the LLMs, this is the cycle. A request comes from the requesting you see here is coming from my ChatGPT prompt, and it has a process. It has a queuing time. It also has a latency because it has to get back the data. And see, the tokens get passed till the time. And in between, I have measures like the TTFT, TTP part, which are like the token latency or a measure that gets, which one gets faster, right? Just like the stack that we have first come, first served, the TTFT is a similar thing. It processes the first token that came. So see, if I get the first token FCFC based, I gave 2 or 3 prompts, right? The latency that adds, there should be a queue coming in. And that's why we see that after a time, the decode latency is added and the inferences. I passed 2 or 3 prompts. I said, hello, Miss World, India. I said, hello, Miss World, Afghanistan. I said, hello, Miss World, USA. I want to see in my chat board if they respond. So how do I get it, right? It has to go and see whether USA that matches or not, the string matched. It has to get back. And that's where the latency is seen. So latency is the overall time it takes the model to generate the full response for the user. Are you visualizing what I'm saying? From the, I developed a chatbot in my mobile app or it's running on the website. I said, hello, Miss World, India, Miss World, USA, and Miss World, Afghanistan. It has to get back. Very less likely, not everybody might know English. Then it has to translate too, right? So this is where we want to talk about the latency and all these things in the modern applications. And this is how, this one, the figure that you see, I picked it from the Amazon. For the reason that they are offering Bedrock and all that, some of them are the open libraries where you people can try a little lesser cost. And whatever I spoke, like the DeepSpeed, you can see there, right? The model compression technique in the model serving. There's a SageMaker, which talking the parallelism, and all of them do see talking about the accuracy and performance. That is what matters when it comes to the LLMs. I'm going to something model and data parallelism. We spoke about the parallelism till now, which is setting a context to search the inference that I passed. So what happens in a model parallelism is it is partitioning a machine learning model among multiple devices, where each device stores a portion of the model and processes data locally. This is more like a cache concept that you see in your web applications or some other full stack applications. Imagine it that way. This model is adapted only when it is too large to fit in a single device. That's where we spoke earlier. I spoke about CPU devices. If it doesn't fit, definitely have to go for a multi-core capability. But what happens if I fit it in a single device is it reduces the memory usage on each device. However, effective splitting the model can be challenging and inefficient. We don't know how to split the data that I gathered, the videos or the text related articles, but my chatbot has to look for the data and bring back, right? So how it can do is it has to split, it has to search. There is a overhead that happens in the synchronization. If you see below the layers, if I don't talk about CNNs, RNNs, it's all the IP transition that happens, right? So that's where the communication overhead happens when it talks to the host or the transmission layer or application layer and getting back to the data. Only thing that from the full stack experience is we don't have a database over here. The database is a LLM mounted on a particular GPU or a CPU. It is easy to understand, relate for all of you, if some of you are new to this particular terminology. So I'm talking about model parallelism because I'm still not sure of what data I want to retrieve. The model here in the context of a Miss World is it's a beauty pageant. That's all. I'm saying, I am not saying a USA or a Miss India. I'm just saying a model is a beauty pageant, a women event. That's all. So this model parallelism means that it is a computational node, is responsible for parts of the model by training the same data samples. So if we want to build a predictive model, who would win? Probably here is where I influence to the past events where this particular, if I want to see the chance of Miss India winning in the Miss World contest, right? So what I do, have to build a predictive analytical model, in which case I dig down the data from the data center with the past servers. That is the communication cost and the overhead I have to pay when I build a predictive model. But then from my chat GPT or the chatbot, it's just a single that the percentage of Miss India 25 can win. So when it comes to the model is divided into several pieces, and each computing node, such as GPU, is responsible for one piece of them. See, even in a CPU, I probably have int, bytes, all these arrays. But in a GPU, it has only one piece of information that is called core. The communication happens between computational nodes when input of a neuron is from the output of the other computational node. That's where you can visualize the graphical weights that happen and the neural networks talking to each other if you can visualize. Now come to the data parallelism. Is another parallelism technique which talks about the multiple processes. I'm not saying it is cores here. I'm talking about the processes in a parallel computing environment. This is all parallel processing actually. It focuses on distributing the data across different nodes which operate on the data in the parallel. So it is like a data structures and arrays and matrices coming into the play, right? So this is where in the rack context today that we can see a vector database or a vector graph or some other graphical database being used. So when it comes to data, do understand it's a task, but when it comes to model parallelism, it's still not having a data structure. So this is where the convolution network CNNs does happen. My interest is not to talk about the picture here, it's just for visualization, but just to portray that how the CNNs talk. That is what I was talking in earlier slide. The batches being trained, how they talk to each other, the computational tasks happen in the model and the data. In this diagram, the upper side one is the model, the downside is the typical CNNs on the data parallelism. But do remember that the performance of a model parallelism is often worse than the data parallelism. Because the communication expenses from model parallelism are much more than that of the data parallelism. The simple reason for that is I don't have a data structure in place when I talk about the model parallelism. That's it. And there I'm talking about the post being taken, which is a very raw, a very low level. But when it comes to data, I do have data structures. And this is where the big data sits most of the times. Your big data pipes or anything, if you take Azure Databricks or anything. That's the reason I actually use the AWS SageMaker there. So we do have a lot of pipelines they can build when we want to work with the chatbots. We do have something like I spoke about 16 and 32-bit, but we do have the model and mixed quantization and the precisions. This is where the neural networks stop. I'm just giving this as a just, I don't want to get into this at this point of time. But I want to talk about the need for specialized LLMs. Like I've been saying, it is mostly cost, performance, scalability. What is the fun if I cannot get the predict at who will win the Miss World 2025 when I have so much of data from last 20-25 years? I've been hearing right from Aishwarya times. At least I know from Aishwarya time that maybe 2000 onwards, I have the data in the world. So I can't predict who would win. What is the fun, right? So integration difficulties are the difficulties that we see in the full stacks as well. So that's where I live, but I talk about the inference frameworks like the TensorRT, LLM, NIM. They have different types of applications. The DeepSpeed is a very famous one. And when I say TensorRT, LLM from NVIDIA is to optimize the inferences on the GPUs. And NIM is another open source library, simplifies the deployment. One is the model parallelism, the other is just a deployment. Do remember that. And DeepSpeed, we spoke about the scaling. This data I took from Gartner or somewhere. It says that 78% of the enterprise organizations are planning to implement LLM powered applications by the end of 2025. And we are in the mid now. So I have to see how it goes. So usually LLM workloads falls into one of these categories like inference, fine tuning, and pre-training. We have been speaking about those. And this is the example I have. I just imported a PyTorch. And you see that I imported NN as a model. And it's like any other code that you do for predicting a SPACY or NLTK. But the end is like I get a prune model out of that. And you can see that I use the linear model here. The weights have been computed. It removed. This is the backend code that I work when I give it to the chatbot, right? And I use the transformers. Please see here. From transformers, I can say a but transformer if I want to use. So the inference landscape is these many players are in the place. And we all know these old llamas, big llamas, all that thing, right? The bedrock and all that. And one interesting thing is please note the GPU providers where the serverless is like A100 has been very popular from NVIDIA in the recent past. That's shown more performance. And this is what we all has to know, like the cost we pay. So we do have a lot of evaluation libraries from Hugging Face, NLTK, BirdScore, all these things. Like I said, LLMs are still in the file. So this is where I want to stop today, and I would like to take some questions. Maybe I'm not sure how much I was able to translate my knowledge as a distillation pattern. So I pass here. Thank you, Karen.
Thanks, Anupama. So yeah, we'll open it for questions. Anyone has anything for Anupama based on what she just spoke about, or anything you have doubts on?
I think I do have some questions in the chat GPT. What about AMD? AMD is good, but then NVIDIA is the topper right now. Everybody is benchmarking with that.
And then we'll ask for the recording.
Let me pick up the questions. Let me see how much I succeed to help you. I don't have a GPU to demonstrate, otherwise it would have been fun. So please let me know what questions I can help.
If anyone has any other questions, you can either unmute yourself or put it in the chat or put it in the Q&A section.
I know it is little boring topic to understand all this, but then being a founder, I have been actually 20 years I worked strongly in the multinationals. Then I never bothered what cost my project does, what code the code I write, what it does, other than the performance and scaling. But when I became an entrepreneur, because I have to pay money, I started looking into these things. And one thing interestingly is I had one interaction. I've been speaking about the same topic in different forums. E2E Cloud is one company which was inviting me repeatedly because this topic is very close to them. And that company was providing a fine-tuned LLMs for different incubators or students to do experimentation. What I learned there is, despite we do all these things, we don't really get a full application that can perform and get me the 95% accuracy data. In medical devices and healthcare, we have to must and get a 95% inferences, be it a text message or voice message or retrieving health records. So there are different fine-tuning techniques that people do spend time on that, especially quantization is one great example that works. Pruning works when we want to do a kind of text removal, but the quantization media applications require a lot of quantization till 32 bit. It's more like compressing what you want to do. And you all know GraphQL kind of libraries in place, right? So that's where we use them. I do some consulting as well. So I get into these shoes, helping them to create a better pipeline, those. So what I mean to say is like LLM inference plays the key role because we have to get the right data, but then do look around what other could miss in the end-to-end architecture of your application. So please let me know what questions you have.
I guess you were pretty clear with what you explained. So I don't see any questions, Anupama. If anyone has anything else, Anupama, maybe you could share your email ID or contact
And
information
they're available
in
in
the
the.
chat.
No, I think the way this is to be made more interactive is to everyone. I am part of the Hyderabad chapter. Please shoot me the chat messages over there. I'm willing to answer. No questions
Yes.
makes me to say that was it a real boring session?
I'm putting the Hyderabad group chat on the.
Probably this session, the topic is not right for this audience. No, I did not for CGU GPTQ in this. If anybody wants to share, they can be Mala, you can speak. Because I was the first one initiated this discussion, I was thinking I'll give some kind of a get head. Vimala, would you like to speak about the CGF and GPTQ? No response.
No, she said she wanted to know about it versus speak.
Yeah, I can clarify this on the chat itself. I am just waiting for more questions. My agenda over here is to think more from the developer perspective where I can develop and deploy. Okay, no more questions, right?
Yes.
So please feel free to talk about, share them in the question. I'll be able to do it.
All right, Anupama, we'll wrap up for this evening.
Thank you. Thank you, Karen.
Thanks, everyone. Yes, thank you. Thank you, Anupama. Have a good evening, all.